we are going to go for lag compensation. Lag means I'm going to add a capacitor, because in capacitor, voltage lags. In capacitor, voltage lags current. So if we reduce the crossover by a high frequency, I'm going to add in the previous network and this circuit. If you see, I'm going to have an additionally capacitor C in series with R. That is the only difference I'm going to make to this circuit. So this capacitor prevents the compensator for having any effect on DC and low frequency. For low frequency, the capacitor will act like an open circuit, right? So that means there is no effect of R in the circuit for DC and low frequency. Only after a particular frequency, the capacitor starts getting included in the circuit. So that is why this is called as lag compensator. So once again, this compensator has no effect on the op-amp characteristics, but it will just work properly for a low frequency and DC. So the same way you see in the transfer function, R1 by wherever I have R, it is going to be R plus 1 by S. You see this combination of R and capacitor. So you can simplify and you get it. So you get you get a first order term, a constant term, and the transfer function. Okay, so you get three terms here. So the term in the brackets, when we consider as transfer function of compensator, the first term is going to be the transfer function of compensator, while the rest of the equation minus that loop is going to be uncompensated system. Okay, so when at DC, the transfer function is unity, because that the capacitor will be open circuited, and at high frequency, the capacitor value, the transfer function will become purely resistive, because capacitor is going to be short circuited. That is lead compensation, lag compensation. So C of S will contain 1, 0 and 1 pole. See this equation. I have 1, 0 and 1 pole. Okay, it has 1, 0 and 1 pole, and the pole is always at a lower frequency than 0. It is going to be at lesser frequency than 0. It is this pole which causes the magnitude to decrease. And now, unfortunately, the side effect is going to be negative phase shift. When you have negative phase shift, the stability is going to be a big question mark. Okay, as this name indicates, phase lag. That is, the phase margin being negative is going to be the phase lag. And we have to make sure that the lagging phase shift is cancelled by the zero, so that the stability is going to be unaffected. So obviously the phase margin will rather degrade and than improve. So simple procedure is to begin with a reduced gain compensator, which will discover the value of R, so that the appropriate phase margin is obtained. So for that, we use the relation RC equal to 10 by omega C nu. Our capacitor will be 10 by R into omega C into nu. So use the formula to find out a specific value of C, which is going to help the